This video is about sum and a product of the roots in quadratic functions. First of all, let's talk about different forms of quadratic functions. Standard form will be y equals ax squared plus bx plus c. Factored form a times x minus x1 times x minus x2. Vertex form a times x minus h squared plus k. For quadratic function, we have an axis of symmetry. X equals h equals negative b over 2a. Also equals x1 plus x2 over 2. For vertex, hk, k equals f of h. We also have a vertex form. This s equals x1 plus x2, and a product that is x1 times x2. Y equals ax squared plus bx plus c. Let's take a out. You will get x squared plus b over a x plus c over a. For factored form, y equals ax minus x1 times x minus x2. Let's do the for you. You will get x squared minus x times x2 minus x1 times x plus x1 x2. We organize x squared minus x1 plus x2 x plus x1 x2. Then we will put a before that. You will get a times x squared minus x1 plus x2 x, then plus x1 times x2. We will compare these two forms. They must be equal to each other. You could say b over 2 equals negative x1 plus x2. c over a equals x1 times x2. Let's write down negative x1 plus x2 equals b over a. So x1 plus x2 equals negative b over a. x1 times x2 equals c over a. S stands for sum of the roots equals negative b over a. Product of the roots equals c over a. Then we will substitute this x1, x2 using s to replace x1 plus x2. Use p to replace this x1 times x2. We will get y equals a x squared minus x1 plus x2 will be sx plus x1 times x2 will be p. We call this is a vertex form. Let's go to number 5. Find the quadratic function if a, 4, -1 are the two roots with the y-intercept -9. For y equals, so we are given x1 equals 4, x2 equals -1. x1 plus x2, that equals 4 plus -1 equals 3. x1 times x2 equals 4 times -1 equals -4. This is a sum. This is a product. We can use a Vertex form. A times x squared minus sx plus p. That is a times x squared minus 3x minus 4. Since you are given this y-intercept 0, -9, x equals 0, y equals -9, we can plug in. You will get -9 equals a times x is 0, so 0 minus 3 times 0 will be 0, minus 4. Organize, -9 equals -4a. Divided by -4 both sides. We will get a equals 9/4. Then the third step, y equals 9/4. X squared minus 3x minus 4. Do the distributive property, 9/4 x squared minus 27/4x, then minus 9. The quadratic function will be this. Let's talk about conjugated root theorem. All irrational and complex roots appear in conjugate pairs. For irrational roots, if a plus square root of b is a root, then a minus square root of b must be the root. For complex roots, if a plus bi is the root, then a minus bi must be the root. If 6 plus square root of 3 is a solution, then so is 6 minus square root of 3. Negative square root of 5 is a solution, then so is a positive square root of 5. 5 minus 7i is a solution, then so is 5 plus 7i. 3i is a solution, then so is a negative 3i. Let's go to b. 2 plus 3i is one root with a y-intercept 7. According to the conjugated root theorem, we know 2 minus 3i is also the root. Let's label x1 equals 2 minus 3i, x2 equals 2 plus 3i. x1 plus x2 equals 2 minus 3i plus 2 plus 3i. Combine like terms equals 4. x1 times x2 equals 2 minus 3i times 2 plus 3i. For conjugate multiply, we do know a plus b times a minus b equals a squared minus b squared. But a plus bi times a minus bi equals a squared minus b squared I squared. We do know I squared equals -1. So we have a squared plus b squared. Therefore, we can get the 2 squared plus 3 squared equals 13. Then we go to Vertex form. Y equals a x squared minus sx plus p. This is the sum of the root. This is the product of the roots. Then we substitute. You will get the a times x squared minus 4x plus 13. This is the first step. Second step, since the y-intercept is 7, we can write down 0, 7. This is x, this is y. We do the substitution. 7 equals a times 13 because x squared minus 4x will be 0. A equals 7 over 13. Therefore, you will get y equals 7 over 13 x squared minus 4x plus 13. Distributive property 7 over 13 x squared minus 28 over 13x plus 7. This is the quadratic function we are looking for. Let's go to C. 3 minus square root of 6 is 1 root with the y-intercept -1. So we have x1 equals 3 minus square root of 6. x2 equals is a conjugate 3 plus square root of 6. For s equals x1 plus x2, that equals 3 plus square root of 6 plus 3 minus square root of 6 equals 6. For p equals x1 times x2 equals 3 plus square root of 6 times 3 minus square root of 6 equals 9 minus square root of 6 squared will be 6 equals 3. So we have y equals a x squared minus 6x plus 3. This is the first step. For second step, using this information, y-intercept is 0, -1. So 0, -1. X, here is y. We do the substitution. -1 equals a. 0 squared minus 6 times 0 plus 3 will be 3. So a equals -1 over 3. Third step, y equals -1 over 3 x squared minus 6x plus 3. Then distributive property equals -1 over 3x squared plus 2x minus 1. This will be the quadratic function we are looking for.